4.4 Indefinite integrals, part A. Number 1, indefinite integrals. So integral f of x dx is co-indefinite. So it's actually equal to a function, indefinite integral, or we can say it's the antiderivative of little f. So our indefinite integral f of x dx is equal to big F of x, where big F of x derivative is equal to little f. Okay, so note, we need to distinguish very clearly between definite and indefinite integrals. As we already know, the definite integral from a to b of f of x dx is equal to a number, or the area under the curve, f of x, and our indefinite integral, f of x dx, is a function, or a family of functions. Example, integral x squared dx is equal to, so the antiderivative of x squared, we already know it's x to the third over 3, plus c, where c is a constant, and that's true because we can check it. So the derivative of our antiderivative is equal to 3x squared over 3, exactly x squared. However, our definite integral from 0 to 1, as we saw in the previous sections, is equal to a number 1/3, which is represented by the area of the region under f of x from 0 to 1. So this area here is 1/3. So let's list some formulas for indefinite integrals, or we'll say table of indefinite integrals. Okay, the first one we know, integral of a constant times a function dx. The constant can go on the front, and it's integral f of x dx. If I have integral of a sum, f of x plus g of x dx, that is integral f of x dx plus integral g of x dx. And the same formula is true if we have minus here. And then we'll have minus here. The next one, if I have integral of a constant dx, that is the constant k times x plus c. And the power rule, integral of x to the n dx is equal to x to the n plus 1 over n plus 1 plus c. We saw this formula in the previous chapter when we studied antiderivatives. So this formula is true for every n not equal to -1. And now the trig formulas, integral of sine of x dx is equal to negative cosine of x plus c. Integral of cosine x dx is equal sine of x plus c. Integral secant squared dx is equal to tangent of x plus c, and integral of cos secant squared x dx is equal to negative cotangent of x plus c. Integral of secant x tangent x is equal to secant x plus c. And finally, integral of cos secant x times cotangent x. Oh, I forgot my dx here. So let's fix that. Let's see. We have a dx here. And that last one will be negative cos secant x plus c. Note, these formulas are valid on an interval. Note, these formulas are valid on an interval where the function is continuous. For example, integral 1 over x squared dx is equal to integral x to the negative 2 dx. If we use the power formula, that's negative 1 over x plus c. This is true with the understanding that this is valid on what interval? All real numbers except 0. Okay. Example. Find the general indefinite integral. So integral of 10x to the 4th minus 2 secant squared x dx. So we're going to use rule number 2. We have integral of sum, and we can write this as integral of 10x to the 4th dx minus integral 2 secant squared x dx. We can put the constant on the front and integrate. That would be x to the 5th over 5 minus 2. And integral of secant squared, we know it's tangent of x plus c, one constant for both integration. So that is 2x to the 5th minus 2 tangent of x plus c. We can always check by differentiating. So take the derivative of your antiderivative, your answer, and you should get the integrand, 10x to the 4th minus 2 secant squared x. So check this out. Another example, integral cosine theta over sine squared theta d theta. I can break this down as cosine theta over sine theta times 1 over sine theta d theta. Now, cosine over sine, we know it's cotangent. 1 over sine is cosecant. And this is one of our formulas earlier, cotangent times cosecant. Right here, the last formula, that's negative cosecant. Okay, and we're adding the constant always when we do indefinite integrals. Another example, integral, this time definite integral, from 0 to 3, x to the 3rd minus 6x dx. Find the antiderivative of x to the 3rd, that's x to the 4th over 4. Evaluate it. I'm going to evaluate each one separately. Minus 6, the antiderivative of x is x squared over 2. Evaluate it from 0 to 3. There's more than one way we can do this. So I like to separate the constants. 1/4 in this case, 3 to the 4th minus 0 to the 4th minus 3. 6/2 is 3. So 3 squared minus 0 squared. So that is 1/4 times 81 minus, that's 9 times 3 minus 27. So that is equal to negative 6.75. So that was definite integral, and that's why we got a number. Next example. Indefinite integral this time, integral of 4th root of x to the 5th dx. Let's rewrite this radical using fractional exponents. That's x to the 5/4 dx. And now we're using the power rule. 5/4 plus 1 is, I will write it down so we know what we're doing. 5/4 plus 1, and then plus c. So that is equal to x to the 9/4 over 9/4 plus c. So it's equal to 4/9, x to the 9/4 plus c. All right, another example of indefinite integral. I think this is interesting because we have a product, square root of t over times t squared plus 3t plus 2 dt. So we don't have a formula for integral of a product, so we need to perform that multiplication first. T square root of t is t to the 1/2, and I'll multiply it by everything inside. All right, so now I'm gonna simplify each term. So that's gonna be t to the 2 plus 1/2 is 3/2 plus 3t to the, is that right? Let's see. 1/2 plus 2, that is 5/2. So let's fix that. 2 plus 1/2 is 5/2 plus 3t to the 3/2 plus 2t to the 1/2 dt. And now we can integrate each one separately. So that becomes t to the 5/2 plus 1, 7/2 over 7/2 plus 3 times t. 3/2 plus 1 will be 5/2 divided by 5/2 plus 2 times t. 1/2 plus 1 is 3/2 divided by 3/2, and plus c, of course. So simplify this is going to be 2/7, and then t, and this is equal sign, t to the power 7/2 plus, if I multiply by 2 here, that's going to be 6/5 t to the 5/2 plus, if I multiply by 2, that would be 4/3 t to the 3/2 and plus c. Another example where we have to simplify the integrand first before we integrate is 1 plus square root of x plus x over square root of x dx. Again, we don't have formula for integrating a quotient, so we need to write it as a sum or difference of power functions. So I'm going to divide each term by square root of x and simplify. Okay, so that is x to the negative 1/2. We want to write this as a power function. And then these two cancel, so plus 1. And then plus x to the 1/2. So if you subtract, the exponent is here 1, the exponent here is 1/2. 1 minus 1/2 is 1/2. And this is dx. So each one of those is a power function. and we can integrate it. So that would be x to the negative 1/2 plus 1 is 1/2 divided by 1/2 plus x to the 1/2 plus 1 is 3/2. Sorry for the break. This is x to the 1/2 plus 1, x to the 3/2 divided by 3/2, and then plus c. So all we have to do is simplify this, and that becomes 2 x to the 1/2, which is square root of x, plus x plus 2/3 x to the 3/2, and plus c. And that is as good as it gets, so we can just leave it like this. One more example with trig functions. So we have integral of 2 plus tangent squared of theta d theta. And if we break it down into two integrals, we don't have a formula for integral of tangent squared. So we're going to do something else. We're going to separate 1 plus tangent squared theta and then plus 1. Because this is a trig formula, 1 plus tangent squared theta is secant squared theta, right? So let's write this down here. So we have 1 plus tangent squared theta is equal to secant squared theta. And that's the formula we're going to use. So now that's equal to secant squared theta plus 1. All right, so now we can break it down into two integrals. Integral of secant squared theta d theta plus integral of 1 d theta. And now this is formula that we're familiar with. That's the tangent of theta, and then plus theta plus c. And that concludes part A.